Our topic for today is laws of reflection.
Good job.
What happened to our light?
No idea.
I have an idea.
Really?
Consider this ray of light which strikes a mirror. This ray of light is called the incident ray. The point at which the incident ray strikes the mirror is called the point of incidence.
Let's go up.
Draw a line perpendicular to the mirror through the point of incidence. This line is called normal. The angle which the incident ray makes with the normal is called the angle of incidence.
It's still not working.
My idea is not over yet.
When the incident ray strikes the mirror, it will bounce off the mirror. The ray which bounces off is called the reflected ray. The angle which the reflected ray makes with the normal is called angle of reflection. Let us learn the two laws of reflection. The angle of incidence is always equal to the angle of reflection. If the angle of incidence is 30 degrees, then the angle of reflection will also be 30 degrees. Remember that these angles are always measured from the normal, not from the mirror. The incident ray, the normal at the point of incidence, and the reflected ray all lie in the same plane.
Based on the nature of the reflecting surface, there are two types of reflections: regular reflection and irregular reflection. Regular reflection is caused by a smooth surface where all the light incident on the surface is reflected in a definite direction. Regular reflection is caused by plane mirrors, still water and other smooth surfaces. Irregular reflection, also known as diffused reflection, is caused by irregular surface of the objects. The irregularity in the surface makes the incident light bounce back in different directions. Wood, wall, and other such irregular surfaces cause irregular reflection. Plane mirrors have flat, smooth surfaces. Plane mirrors are most commonly used for personal grooming, decoration, and architecture. These mirrors are constructed by coating silver on one side so that the other side can reflect smoothly. To see how an image is formed in a plane mirror, let us do an experiment. Consider an object in the shape of the letter P. From a point X on the object, consider a light ray incident on the mirror at point A. According to the law of reflection, the angle of incidence is always equal to the angle of reflection. Observe the angle of the incident ray as it reflects and travels to the eye. From the same point X on the object, another light ray is incident on the mirror at point B, and the reflected ray travels to the eye. The two reflected rays from A and B are divergent. When extended beyond the mirror, these rays meet at X dash. Thus, the image of the point X on the object is formed at X dash. Consider one more point Y on the object. A light ray from Y on the object is incident on the mirror at C, and the reflected ray travels to the eye. Similarly, another ray from Y on the object is incident on the mirror at D, and is reflected to travel to the eye. Like the two rays from A and B, the two reflected rays from C and D are divergent, and when extended beyond the mirror, meet at Y dash. Thus, Y dash is the image of point Y on the object. Similarly, rays from all points on the object are incident on the mirror. All these divergent rays are extended beyond the mirror to form the complete image of the object. You will also notice that the image formed in this case is erect, laterally inverted, of the same size as that of the object, and the distance of the image from the mirror is equal to the distance of the object from the mirror. These are standard characteristics of images of objects formed in plane mirrors.